Yeah. Okay, on page 615, I wanted you to read that first paragraph and annotate it. Okay? So what were some important underlined things that you included from this paragraph? One?
That he wants to keep greater than or equal to 12 inches long.
Good. That greater than or equal to is important to include with that 12 inches long, right? What else was important? Sydney?
Pat caught a flounder that is 14 inches long.
Good. So he caught this that's 14 inches long. Now, when we're looking at these inequalities in this inquiry lab, this is going to seem very basic, very easy as we're looking at this. It's supposed to be. Okay, so right now most of you are thinking, we know if he can keep this fish or not. Okay, but let's break it down a little bit further. So let's take a look at the investigation down below. So it says an inequality is a mathematical sentence, get rid of that real quick, that compares quantities. We've had mathematical sentences before. What do we call a mathematical sentence before? An equation. So the only difference now is that before, in an equation, the two sides of the equation were equal. In an inequality, they're not necessarily equal. It's a comparison of those two quantities. So an inequality could be something like x is less than 7, or x is greater than 5, can be written to show how a variable compares to a number. So let's label our bar diagram here. What is the minimum length of flounders that may be kept? 12. 12 what? Inches. Okay? What's the length of the flounder that Pat caught?
14 inches.
14 inches. So in the second diagram, let's label that 14 inches as a comparison between the 12 inches. So the 14 inches would be the one here on top, the length of the fish that Pat caught. The bar representing Pat's fish is what? Then the bar representing the minimum length that can be kept. It's greater than. So Pat can or cannot? He can keep the fish because it is greater than 12. Right now, when we start talking inequalities, we would say that the length of the fish, let's call it F, is the length of the fish, has to be greater than what? Greater than 12. Could he keep a 12-inch fish?
Yeah.
No. It said great. Well, did it say greater than or equal to?
Yeah.
Okay, so it's greater than or equal to. Could it be a 12-inch fish?
Yeah.
Yes. Can it be a 13-inch fish?
Yeah.
Could it be an 11-inch fish?
No.
So this right here is what we call the inequality. Okay, and we're going to use that today as we start talking about these inequalities. So look on page 616. Let's do a couple of these. Together we're going to do this question number 1 and question number 3. Let's start with question 1. In order to win a prize, Ephraim needs to read at least 9 books. Ephraim read 8 books. Will he win a prize? Let's start with our bar diagram of what Ephraim read. Okay, he needs to read at least how many?
8.
9. So let's make a bar diagram. This is what he needs. Okay, but Ephraim read how many? 8. So our second bar is what Ephraim read. So in the problem, Ephraim needed to read at least 9 books. What does that mean mathematically? At least tells me, could he read 9?
Yes.
Yes, so we're going to have something with equal to 9 or greater than. So we would say that the number of books he reads has to be greater than or equal to 9. Is 8, which is what Ephraim read, greater than or equal to 9? No. So will he win a prize? No. He will not win a prize. Okay, let's look at number 3. For flights within the United States, luggage must be no more than 50 pounds. That is true. Imelda's luggage weighs 53 pounds. Can she take the luggage on her flight? Well, let's create our bar diagrams to prove it. So they can be no more than 50 pounds. And Imelda's bag weighed how much?
53.
53. Can she take the luggage on her flight?
No.
No. Now, technically, actually, you can. You just have to pay extra money for the luggage. But in this situation, they're telling us she can't. So no, she can't take the luggage on her flight. If we were to write the inequality, we would say that for her luggage, L, must be no more than 50. Can it be 50?
Yes.
Yes. No more than 50. So it could be 50, so we have equal, right?
Yeah.
So is it going to be greater than or equal to or less than or equal to?
Less than.
Less than, because it can't be bigger than that. So less than or equal to 50. This would be the inequality to represent that situation. Okay, and that's actually what question 5 and 6 had you do, is to write those inequalities. We already did it up above, so we're just going to leave it there. Turn to page 617 in your book. You're kind of already there, so just look to the next page. I want you to take a minute and go ahead and fill in what you learn at the top of the page. Take a moment. What were some things that you predict we're going to learn about these inequalities? Alex.
Solutions of inequality.
How to find the solutions of an inequality. Very good. What else? Sydney?
Inequality.
What an inequality is?
Yeah.
Okay, good. What else? You see anything on those pages that look different? How about the symbols? We kind of already know them, right? But are we going to learn the symbols used for the inequalities? Good. Look at our vocabulary startup. So we already talked about this definition. An inequality is a mathematical sentence that compares quantities. So let's just fill that in for our definition. So it's a math sentence, much like an equation, that compares quantities. The difference is an equation did not compare. It was showing equivalence, whereas this one compares the quantities, not necessarily equivalence. If we break apart that word inequality, what does that prefix in mean? Not equal, right? So these inequalities are not equal, unless we're talking about the greater than or equal to or less than or equal to. Then we might have a partial equivalence there. What are our symbols we're going to use? Give me one. Connor?
Greater than equal.
Greater than and equal to. Remember, that's the greater than symbol with half of an equal sign. Good. What else? Delaney?
Less than equal.
Less than or equal to? Good. Less than sign with half an equal sign. What else, Lauren?
Greater than.
Greater than. What else, Brooke?
Not equal.
Not equal. The equal sign with the slash through it. And what's our last one? Brock?
Less than.
Less than. So those are the 5 symbols that we're going to use in our inequalities. Yes?
What about the equal sign?
Equal sign would only be if we're talking an equation. Okay, so inequalities will not have an equal sign. Examples? We could have x is greater than 4. A is less than or equal to 2.5. Those would be examples. Non-examples, give me something that might be an opposite of inequality. What would be the opposite of an inequality? Delaney?
An equation?
An equation, give me one. Using a variable.
Like x minus 4
X minus 4
equals
equals 7. Perfect. Could we use an expression? Who can give me an expression for an example? Use a variable, give me an expression. It's just not equaling something. Brooke?
9a.
9a. 9a plus 5. Good. Look down below. Let's look at the real world link. Now let's use the greater than less than symbols that we know from before to start looking at this. So compare the following using less than or greater than. The score after 2 goals is blank the score after 3 goals. What would that be? Anybody?
Less than.
Less than. the cost to download 10 songs is what the cost to download 2 songs? Greater than. The outside temperature in summer is usually what the outside temperature in winter? Greater than. The height of a first grader usually is what the height of a sixth grader? Less than, usually. The time it takes to eat lunch is what the time it takes to brush your teeth? Greater than. Okay, so let's talk for a minute here about how these inequalities happen in our real world. Because you see inequalities actually around you often. For example, if someone is told in the United States that their age, A, has to be 18 years or older to vote, their age would have to be what to 18? Greater than or equal to 18. If their birthday fell on the day of the vote, could they vote?
Yeah.
Yep, because they would be considered 18. Now, if their birthday was the day after the vote, could they vote? Nope, because they would still be 17. Okay, so they could be greater than or equal to 18. So somebody who's 90 has the right to vote. Somebody who's 18 has the right to vote. Somebody who's 17 does not have the right to vote. So this is a practical inequality. Can you think of any other situations where you might see something like an inequality? Brooke.
The measurements on the slide.
Okay, so like adventuring. Is that what you're talking about? Like that's
All
all
you have to be
to ride a ride or go down the slide or whatever. So for example, let's say you go to adventuring and your height has to be 48 inches to ride the space shuttle. Okay, how would you show that as an inequality? Your height has to be 48 inches or taller to ride the space shuttle. What would you write, Lauren?
greater than or equal to.
Greater than or equal to. Could you write it if you're 48 inches tall?
Yes.
Could you write it if you're 47? Not unless somebody's not checking. Right? Okay, but this would represent a situation where your height has to be greater than or equal to 48. Some of the children's rides, they'll tell you have to be less than 48 inches. How would you show it if you had to be less than 48 inches?
48.
Right?
Less than.
Yep. Because they said less than, it couldn't be less than or equal to, right?
Yeah.
Okay, can you think of any other times or situations where you have to be at least something or a comparison of something? Raise your hand if you went to the track clinic last week before break. Okay, what were the stipulations for the track clinic? You had to be 4th through 8th grade, right? So you had to be at least a 4th grader, or at most an 8th grader. If you were a 9th grader, could you go?
No.
If you were a 3rd grader, could you go?
No.
If you were a 6th grader, could you go?
Yes.
Okay, so we had stipulations there. Is that an inequality? It is. Comparing those quantities. Okay, giving you restriction. Trevor.
To drive.
To drive, what do you have to be?
16.
Permit is 14. Let's talk real life rules.
16.
So the driver's age has to be,
16. Well,
how are we going to compare to 16?
um,
Greater than or equal to. Can they be 16?
yes.
Yeah, but can they be older than 16?
Yeah.
Yep, most of the time. Sometimes their license gets revoked if they have other reasons, but that's the beginning restriction. Good. So do you see how these inequalities are a real world event, something that we actually do? Right, now, are we always going to sit down and write out an inequality to represent these? No. But you have to remember that a lot of the things that we do in math aren't necessarily things that we do on paper and pencil. They're things that we apply to the world around us. Do we have to understand the relationship that if you are going to have to be at least 16, do we have to understand that you can be 16?
Yes.
You can be older than 16? That relationship is really the understanding that we want to build. And we're going to build it through using numbers and writing things in. Okay? So that hopefully we continue to get better and better and better at that understanding. Does that make sense? Turn the page then to page 618. Bless you. At the top of the page, you see these symbols we talked about. You see less than, greater than, less than or equal to, greater than or equal to. They do have some key words there if you need them. Okay, they've got is fewer than, is more than, at most, at least, Okay, you might see things like maximum height to ride this can be 48 inches. Or sometimes you see on bridges, when you're driving, right? Like overhead clearance is such and such. Well, if your overhead clearance is taller than that and you want to keep driving your truck down that road, I know, you're going to lose the top off your truck, okay? You're going to smash right into that bridge. So those are important keywords for us to understand. Look at example 1. So here's how we're going to solve this in mathematical land. Of the numbers 6, 7, or 8, which is a solution of the inequality f plus 2 is less than 9? So all this really is taking our work with equations, and now we're just comparing quantities. Okay, the only thing that's new is our thinking. Okay, that's the only thing that's going to change. Our math is really staying the same. So we're going to substitute those values in. If I take 6 and put it in here, what's 6 plus 2? 8. Is 8 less than 9? Is that true?
Yeah.
So could 6 be an option?
Yeah.
Yes. So I'm going to circle it. Let's substitute 7. If I put 7 in here for f, 7 plus 2 is 9. Is 9 less than 9?
No.
That doesn't work, so I can't include 7 as an option. It doesn't work in that inequality. What about 8? 8 plus 2 is 10. Is 10 less than 9? No. Nope. That doesn't work, so I can't include 8 as an option. So the only possible solution from that list is 6. Are there other solutions?
No.
Give me another solution that would work in this situation. Lauren?
4.
4. If I put 4 in place, 4 plus 2 would give me 6. Is that less than 9?
Yes.
That would work. Give me another one, Delaney.
5.
5. 5 plus 2 is? Is that less than 9?
Yes.
Brock?
1 plus 2.
1. 1 plus 2 would be 3. Is that less than 9? Okay, so with equations, how many solutions did we get? When we solved equations, how many answers did you have?
1.
You had 1, right? With inequalities, are we going to have more than one solution possible? Because it's a comparison, we can have more than one solution possible. Just like when we're talking about driving a car. You could be 16, you could be 35, right? Those solutions all work for that restriction. So there's going to be more than one possible solution. Now here, we have a list. So the only possible solution from that list that worked was 6. Okay, and when you do this on your homework, I am 100% fine if you show me this. You just circle it and cross them off. Okay, you don't have to write anything else down below. Right. Does that answer your question? No, you can just circle the solution there. We'll get to that later on. Take a minute and I want you to do, got it, letter A. Alright, let's take a look. Let's substitute. If I put 8 in, what's 8 minus 3? Is 5 greater than 6?
No.
That does not work, so 8 will not work. If I substitute 9, 9 minus 6 is? 9 minus 3 is? 6. Is 6 greater than 6?
Nope.
Nope. So 9 won't work as a possible solution. Let's substitute 10. 10 minus 3 is? 7. Is 7 greater than 6?
Yes.
That one works, so 10 is the only possible solution here. How did you agree? Good. Any questions on those types of problems? Okay, let's look on 619 then. This isn't going to change a lot, but it's going to change a little. Okay, so now we're going to look at, they've given us a solution, they want to know if this is true. Pay attention here at how we're going to actually write this. So we're still going to substitute. They told me that x is equal to 4. So that means I'm going to put 4 in place of x, right here. So if I put 4 here, 4 plus 3 is? 7. Is 7 greater than 9? No. So we would say because 7 isn't greater than 9, 4 can't be a solution. Here's the shorthand. I want you to write this with me. Okay, so you don't have to write a big long sentence. You can say it this way. Because 7 is not, I'm going to put a slash through it, is not greater than 9, x is not equal to 4. Does that make sense? Or if you don't want to write because, you could say it this way. 7 is not greater than or equal to 9, so x is not equal to 4. Either one of those would be fine for your final answer. Does that make sense? But you got to show both parts. You have to show me this part here, and you have to show me this part here. If this part here is not equal, should this part be not equal? Yes. Look at number 3. 12 is less than or equal to 18 minus y. If y is 6. Well, if I substitute 6 into there, what's 18 minus 6? 12. Is 12 less than or equal to 12?
Yes. Equal.
Yeah, it's equal to. So we would say 12 is less than or equal to 12. So, what does that tell me?
So it's 12 is equal to 12. Yeah, it's equal to.
So what?
Equivalent.
What's equivalent?
To y.
Not to y.
To 6.
So 6 is a solution, right?
Yeah.
So y equals 6. Because what we're trying to do is we're trying to prove if this is true or not true. So we have to say, yes, if this is true, 12 is less than or equal to 12, then y is equal to 6. If that's not true, then y can't be 6. Okay, let's look at the next one, number 4. $17 is greater than or equal to 11 plus x if x is 8. Well, if I substitute 8 in here, what is 11 plus 8?
19.
So 17 is greater than or equal to 19. Is that true?
No.
We substituted these here. We did that. Replace x with 8. So because these are not equal, 17 is not greater than or equal to 19. So what does that tell me?
Y. No.
X is not equal to
8.
8. This would be my final answer. Okay, since 17 is not greater than or equal to 19, 8 is not a solution. Does that make sense? So you can use that shorthand if you don't want to write out a big long sentence. If you want to write out a big long sentence like that, since 17 is not greater than or equal to 19, 8 is not a solution, that is also fine. Okay? Take a minute and I want you to work on these 4 got it's at the bottom of the page. Go ahead. Okay, letter B. Help me out here. If I substitute 9 in, 9 plus 7 is what?
12. Oh, 9.
Try again. 9 plus 7?
I thought you were talking
16. Is 16, excuse you, is 16 greater than 15?
Yes.
Yes, so A is equal to 9. How do you agree? Good. Letter C. If I substitute 6 in for B, 15 plus 6 is? 22 is less than or equal to 21. Is that true?
Yes.
No, 22 is not less than 21. It's greater. So, B is not equal to 6. Good. Please listen. Letter D. If I substitute 10 in for N, 10 minus 4 is 6 is less than 6. Is that true?
No.
That's not true. So, N is not equal to 10. How do you agree? Very good. And letter E. If I substitute 7 for G, 5 plus 7 is?
12.
So 12 is greater than or equal to 12. Is that true?
Yeah.
So, G can equal 7. How do you agree? Good. Any questions on that set? Okay, then turn the page to the top of 620. Let's look at how this works in the context of a problem. I want you to read that problem to yourself and underline anything that's important. So what are some key things that you included when you underlined? Delaney?
B greater than 20.
Okay, B has to be greater than 20. Do we really need anything else? No, B has to be greater than 20, but what does B represent?
The number of balloons.
The number of balloons. So do you agree that in the table we have the number of balloons sold? In order to be included for a bonus, they're going to have to sell more than 20. Can they sell 20?
No.
No, it said
More
than 20. So they'd have to sell at least 21. So which months have balloon sales that are more than 20? July, because it's 25, and October. So our answer would be July and October they received the bonus. Look at question 5 in the guided practice. Underline anything important. What's the key thing that you underlined here? Trevor? True, which tells us it has to be greater than 45, right? Okay, which ones have a number greater than 45? Give me one, Trevor.
Friday.
Friday. Give me another. Peyton?
Saturday.
Saturday. So the only 2 days that they're going to make a profit like that is going to be Friday and Saturday. Does that make sense? Alright, then for homework, you're going to go to page 621. Pay attention, please. On questions 1 and 2, it says determine which number is the solution. Remember, you can just circle and cross off like we talked about. Remember, behind each problem, they give this orange example. That leads you back to an example we've already done. So if you get stuck, look back at those examples. Questions 1, 2, 3, and 4 are like those examples we did. 5, 6, and 7 are like the ones we just worked on. We just need to answer the question. For homework, you're completing page 621, questions 1 through 7. You may get to work now.